This lesson is on simplifying expressions. Before we begin, you need to make sure that you have this note sheet pulled up. So if you don't have it in front of you, take time now to get it and then come back to the video. Okay. Simplifying expressions. An expression is a mathematical phrase that can contain numbers, variables, and operations, or operators like plus and minus, addition, subtraction. An expression, and this is a key word here, an expression will not have an equal sign. An example of an expression would be 2x plus 4. No equal sign. What about a term? A term is a constant. Remember, a constant, it just means a number or a variable in an expression. So in the expression that I wrote above, we have a constant term of 4, and we have a variable term of 2x, because it has that x. Terms are separated by plus and minus signs. So, what are the terms in this expression? How many are there? There's 4. There's 1, 2, 3, 4. There's two ways to look at this. We could say that the terms are 6x, 10y, 13, and 5z, or, let me do better on that z, or we could say that that 10y is minus 10y, because what we're really doing is we're adding a negative 10y. So then we would call this term minus 10y. So that's attached to the term. The number in front of a variable in a term, the number in front of the variable is called a coefficient. So here, 14 is a coefficient, negative 7 is a coefficient, 10 is not in front of a variable, so it's not a coefficient. Okay, realized you couldn't see that very well. So the coefficients, 14, negative 7, we said this is not a coefficient because there's no variable. And then here it's negative 2. Like terms. In order for terms to be like terms, they must have the same base, or variable, or we could say variables because they could have more than one, and the same exponent. Not sure what we're looking for here, but our exponent is like this, x squared. That 2, the squared, is the exponent. So if you have an x and you have an x squared, it's not going to be a like term. So let's look at the next part, and I want you to answer before I give you the answer. So we're going to say, are these terms alike or no? So negative 15x and negative 15, alike or no? No, because they don't have the same base. That has an x, that has nothing there. Okay, we have 1/4 c and negative 9c, like or no? The base is c on both, so yes, they are alike. They are like terms. Next one, 2.5x squared and 3.5x squared. What's the base? X, that's correct. And what's the exponent? 2. The exponent's 2, that's right. So they both have the same base, they both have the same exponent, so yes, like terms. Next one, 6y and 6x. No, they're not even the same variable, are they? What about 30 and negative 25? Yes, that's right, they are like terms because they don't have any variable at all. They're just constants. Constants are always like terms. Next we have 17b and 1/17 b. Like or no? The base is b, that's correct. And they are, the exponent's the same because it's, we don't see it, so it's 1. And so they are like terms. Next one is 10m and 10m squared. No. M and m squared are not the same, they're the same base, but they're not the same exponent. Next one, 2.2n and 2.2. No. Okay, we want to give an example of a like term. I'm going to do a couple of them, and then I'm going to let you do the rest of those on your own. So a like term for 14y could be 15y. A like term for 15b squared could be 5b squared. So you can fill in the rest. So let's simplify some expressions. Oh, this isn't the one. This is the one you'll do on your own. And as long as I have that up, notice that it's got at the bottom, what is a bird's favorite subject? So you'll be able to tell if you got them correct because that is going to make sense at the bottom. Okay, now we're going to try this. We can simplify algebraic expressions by combining like terms. Be careful when you're combining terms to check the coefficient that's in front of the term. Okay, we have a group of friends went to the movies and bought the following: tickets T, drinks D, and popcorn P. Write an expression to represent their purchases. Well, we have 2 popcorns, so that'd be 2p, and then we have a drink there, so that would be, we don't have to write a d when it's just 1, I mean a 1 when it's just 1, we just write the variable d. Here we have 2 tickets, so plus 2t, and then we have another drink, plus d, and then we have 2 more tickets, plus 2t, and then we have another popcorn, plus p, 2 more tickets, plus 2t. See, I'm getting too far away here, so I can't see what I'm writing. 2t, and then last we have another drink, so plus d. So what we want to do is we want to gather up all the terms that are like terms. So everything that has p, let's find those. 1 there, and there's another p. That's all we have. So we have 2 p's and 1 p, so 2 plus 1 is 3 p's. Everything's addition, so we're going to say plus next to that. Then we have some d's. Let's see, there's a d, there's a d, there's a d. How many d's do we have? 1, 2, 3 d's, so plus 3d. Because if we don't have anything written in front of that, we call it a 1, because there's only a 1d there. Okay, and then I can write plus. And I have tickets left, so we have tickets, tickets, tickets. 2 tickets plus 2 tickets, 2 plus 2 is 4. And then we have 4 from those plus 2, so that's 6 tickets, 6t, and there's our simplified expression. Let's try some others. Look for our like terms. We have a r and a r. Nothing goes with the n, so we have 13 in front of the r and 5 in front of the r, so 13 plus 5 is 18r. And then this one we just bring down, plus 2n. And we're done. Okay, here we have w's, w's, w's. Now be careful, this time we have a negative. So we have 1.6, and then we have negative 1.2, and we have positive 4.7. So if we first do this part, we would end up with 0.4, because 6 minus 2 is 4. We have to bring our decimal. 1 minus 1 is 0. Then we're going to add to that the 4.7. So we have 5.1. So we have 5.1w, and then the only thing left here is that 3.5, so plus 3.5, and we're done. Now the next one, we have some fractions. Do you remember how to do fractions? Well, it doesn't matter because they're not like terms. Look at this has a y and this has an x. You see that? That's a y and that's an x. So our x terms, here and here, we still need to know how to do a little bit with fractions. And here's y and here's another y. So negative 1/3 x plus 2x. Well, how many thirds are there in 2? If I take 2 wholes and split them into thirds, then I'm going to have 6 pieces. So that's 6 thirds minus 1/3 gives me positive 5 thirds. And don't forget the variable x. Then I have 15y minus 5 2/5 y. Well, I can subtract the 5 first, and then I would have 10y. But remember the other one we're still subtracting, so we still have 2/5 y. Well, how many fifths are there in 10 whole? 50, that's right, that's a lot, isn't it? So one way we could do it is take 50 minus 2 and get 48 fifths. So that would be 48 fifths y. But another way we could do it is we could say, well, this is less than 1 whole. So if I just take 1 away from the 10, I get 9. So let me say plus 9. And then I take 1 minus 2/5. Well, that would be 5/5. 5 minus 2 is 3/5. So I could just say 9 3/5 y. Don't forget your variable. Okay, and the others work the same way. Here's a perimeter. When we do a perimeter, we have to be careful because they give us the top and this side. But remember, a perimeter is all the way around. So we have to add, this side's going to be the same because it's a rectangle. 17.4x minus 0.8, and this is 6x. So now we just have to add all of those together. So we can say 17.4x and another 17.4x and 6x and 6x, and then we have, well, let's just do those separate. So 17 and 17 is 34. 34 and 6 is 40. 46. And then we still have the 0.4 and the 0.4, so that's 0.8x. So that gives me 46.8x. And then these are minus, we're going to subtract. Well, 0.08 twice is 1.6. And we're done. We have an expression for the perimeter. This equilateral triangle, equilateral means all the sides are the same, so that's just 3/4 x minus q and 3/4 x minus q. And, well, they might have intended that to be a 9, but we're going with q since that's what I said. 3/4 and 3/4 and 3/4. Add the 3's. 3 plus 3 plus 3. 9/4. So we're going to just leave it like that. 9/4 x. And then how many q's? 1, 2, 3. I have 3 q's. Minus 3q. And we're done. So I want you to practice on the simplifying expressions. And I'm going to put that on the Nearpod so that you can do it on there, or you can print it out. If you've already printed it out, you can just do it there and turn it in that way. You have options. See you next time.